Hey everyone, this is our extra practice video for rewriting rational exponents. So here are our objectives for today. We're going to rewrite radical expressions. We'll talk about what those are by using rational exponents, and then afterward we'll be able to simplify them. And there is the standard associated with this. Let's jump right in. So first I want to establish what a radical expression is and what a rational numbers are, because those are both important terms for our lesson today. Radical expressions are things that have a square root kind of sign, this sort of sign. So this would be square root of 2 is an example of a radical expression. Another kind of radical expression, you could have a cube root. So instead of it being a square root, it could have an extra cube in it. And what these mean is these are examples. It's asking what times what equals 2. That's an example of a square root, so radical. So it's asking things times itself. What times itself gives us 2. This one over here is asking something times itself again. What times itself 3 times gives us 2. So that's what those mean. Rational numbers, so that's radicals. That just means if it has that squiggly thing in it, that's a radical. Rational numbers now are numbers that we can write as a fraction, something over each other. So an example of a rational number would be 1 over 2. Or 3 over 2. Those are both rational numbers because we can write them as some number, some integer, like 1, 2, 3, 4, 5, 6, over another one. They can also be negative, like negative 1 over 3 is a rational number. So today we're going to be able to rewrite radical expressions, so these things on the left, by writing rational numbers as their exponents, those things on the right. All right, let's dive in with some examples of this. Let's first say we just had the number square root of 10. This square root is saying, it's sort of like saying there's like a 2 out front here. They don't typically write it. If there's nothing there, they're saying a 2. It's saying what times itself gives you 10. The way we can write that with a radical exponent is by saying 10 raised to the power of, so instead of it being that square root sign, we're going to put to the power of 1 over 2. So a radical is the same as having a fraction in our exponents. Another example, we could do it with the cube root of 10. So if there's a radical like that, we can rewrite it with instead a 10 to the 1 divided by 3. Now these fractions, this is the same as it being divided. So it's like saying what times itself twice gives us 10 in the first example. What times itself 3 times gives us 10 in the second example. We can also combine these. So if we had instead, one more example, say we had the cube root of 10 squared. There's a couple ways we could rewrite this. We know that when we have a radical, so this squiggly, this kind of radical sign, this cube root sign, we know that that's going to turn into, I'm just going to make space, that's going to turn into a 1 over 3. So this radical here is going to turn into a 1/3 exponent. But we also still have our 10 squared in there, 10 squared. So this is one way we could get rid of the radical sign and instead write it as a fraction in the exponent. We could take this a step further. If I kind of zoom in and look at this, I see this 2 exponent in blue and the 1/3 exponent in red. We can combine them because they act just like fractions. They act like fractions normally would. So this is saying going to be 10. Let me get rid of the parentheses. 10 now, and we want to combine these exponents. What operation we're doing here is multiplying. So 2 times 1/3, we could rewrite that as 10 raised to the 2 times 1/3. And we could also rewrite that, if we remember our fraction rules, as 10 raised to the 2 divided by 3, or 2/3. A good way to look at this would be 2 divided by, change the pen size, divided by 3. So that's a really good example of how we could take a radical expression, something with a radical sign that I highlighted here, and rewrite it now as just a number with a rational exponent, 10 raised to the 2 over 3, 2/3. Okay. So that's what we're going to need to do to rewrite expressions. We're going to be able to translate a square root to a 1/2 exponent, a cube root to a 1/3 exponent. And then sometimes we'll work with simplifying them. So let's look at these two examples down here before we move on. These deal with rewriting each of the radical expressions below with rational exponents. These should be pretty straightforward. If you'd like right now, you should pause the video, try these out, write them down, and then restart the video and we'll walk through them together. We'll explain the steps as we go. So try that out right now and then come back. Hopefully you've paused the video and tried these out. I'm going to start writing on this first one. I see there's a radical expression here, a cubed root, and I know from what we just talked about that I can rewrite radical expressions as exponents, fractional exponents, like 1/3 would be a cube root. So I'm just going to take my 10, put it back over here, and rewrite it with 1/3 as its exponent. Let's double check and make sure we did our job. It says rewrite the radical expression below with rational exponents. Great, that's exactly what we did. We took this radical expression here, we rewrote it now with a rational exponent, a 1/3, a fractional exponent. Do the same thing down here. Only thing we have to remember here is that instead of the cube root like we had before, it's not a cube root, this is a square root. So it's like imagining it's a 2 there, it's the second root. So it's saying something times itself. So we translate that to a 1/2. So 7 to the 1/2 is the same as square root of 7. All right, that's pretty much our first objective for this lesson. Our objective was to rewrite radical expressions with rational exponents. Those are simple examples of how we can do that. Next, we want to be able to use those same properties, the same properties that we've been talking about, to instead simplify expressions. So simplifying expressions, I'm going to give us an example here of x to the, let's do square root of x. We'll say all raised to the 4th power. Nope, that's an example we do later on. Square root of x all raised to the 6th power. So looking at this right away, I don't have a lot simpler way to write it. It also looks pretty complicated. There's a radical. There's a big exponent. I would rather just have this, like, I want to simplify. I would just want to have x as my bottom number and then some power up here. Just, it would be simplest if it were just x to some power, not all these crazy parentheses and square root signs. So what I'm going to do is I'm going to take a step in simplifying. I'm going to notice that my x is under a square root sign, which means I should be able to rewrite it as a rational exponent. The rational exponent that goes with square root, like we said before, it's like a 2. So we can rewrite this as x to the 1/2. And we still have this 6th power up here. So that's better because I've gotten rid of the radical sign. Now it's just x, but there's 2 numbers in the exponent. We'd love to combine them. We'd love to combine these exponents into just one exponent. So taking one more step forward, just like we did before, we're going to treat these like any rational numbers, any fractions, and just multiply them. So we're going to be multiplying 6 by 1/2. If we forget how to multiply fractions by a number, we can just rewrite them both as fractions. So here, 6, I'm going to rewrite it as 6 over 1. Now they're both fractions. So I'm going to rewrite this problem down here. We're trying to take 1/2 and multiply it by 6 over 1. When we multiply fractions, we just multiply straight across. So it's going to be 1 times 6. That's just 6. Oops, get a smaller pen. 1 times 6 is 6 on top. And then on bottom, 2 times 1 will be 2. At this point, I should ask myself, I'm gonna update my x up here. Now it's x raised to the 6 divided by 2. I should ask myself, is that as simple as it gets? We definitely have gotten a lot better. We've gotten rid of the radical sign. We've gotten rid of the 2 different exponents. We now just have one number in our exponent, 6 divided by 2, 6 halves. But we should be able to simplify that more, and we might be able to. Let's look at it. 6 divided by 2, if I think about that, when I simplify fractions, I can do the same to top and bottom. I notice I could divide a 2 out of the top and bottom of this fraction. 2 goes into 6 and 2 goes into 2. So if I did that, 6 divided by 2 would just give me a 3 on top, and a 2 divided by 2 is 1. So 3 over 1, or just 3. Great. So actually, we're able to simplify it one step further to just have it as x raised to the just x raised to the 3rd power. So those are a lot of steps, but in reality, I want us to look at the big picture here. We started with this expression, which had a radical here in the blue. It had an exponent extra in red, and it had our variable x. We rewrote it so that it's as simple as x to the 1/3 power. There's nothing there we can simple. It's just a variable with one exponent. All right, 2 examples of this are right down below. Just like before, it would be great if you could pause the video, try out these examples first on your own, then come back and watch me step through them. So hopefully you pause, try these out. I'm going to walk through them right now, though. So looking at this problem, I noticed that there's a radical in blue, and it's a square root, so it's like a 2. It's a second root. And then we have an exponent to the 4th, so I'm just kind of highlighting these things in different colors. So I'm first going to rewrite my radical, because that's a big important thing. I'm going to rewrite that as a 1/2. Now I see, now we have the 2 exponents. I'd like to combine those. When we combine them, we just multiply. So 4 times 2. If I wanted to rewrite the 4, I'd write it as 4 over 1. I see those 2 fractions. I can multiply those. X raised to the, on top it's going to be 4 times 1 is 4. On bottom is going to be 2 times 1, 2. We have to be careful to make sure that they're both on top of each other. They're both in the exponent when we have fractions. I should be able to simplify that a step further and go x to the 4 divided by 2 is just x squared. The next question looks a lot more complicated, but we can apply the same kind of thing. So hopefully you've tried these out. Right down below I see I have a radical 3. So I'm going to rewrite this as y to the 5th on the inside. That's my inside piece in black. And then the blue radical is a cubed root, or a 1/3. And then the last piece on the outside is 3 over 5. So the first thing I did is I just made sure that all of my exponents are in fraction form, in rational number form. Then I just have to multiply them. It's going to be 5/3 times 1/3 times 5. If I wrote those all out in fractions, it's going to be 5 over 1 times 1 over 3 times 3 over 5. That's going to give me 5 times 1 times 3. That's going to be 15 on top over 1 times 3 times 5, 15 on bottom. Well, 15 divided by 15, that's just 1. So that's going to be y to the 1st power, or altogether just y. So I took this very complicated expression that had a radical cube root in it. We rewrote our exponents in rational form, and then we used our multiplication or our fraction rules to simplify it just down to y. For the rest of this skill, just move on to the back side. There are 8 practice problems. You're going to work together with your intervention teacher on those or with other peers. And then at the end, there's one check that you need to try independently to show that you've done the mastery for this skill. All right. Try those practice problems out and get your mastery with your teacher.